Hello everyone. In the previous videos, we have seen about how we can develop different types of neural network models based upon various interfaces and inbuilt tools in Matlab. If you have not yet checked it out, you can look it up in the description about various models which we have developed earlier. In this present video, we will see how we can do the same kind of models using a code. So let's begin with development of a simple feed-forward neural network model. Similar to the parameters which we used in the previous neural network tools, we will use the same parameters, but the control over those parameters would be high when we use this code. This is a code which was developed by me and my mentor based upon reference of various codes and also Matlab toolboxes which are inbuilt in Matlab. So we have corrected the code for our use, and you can use this code for your purposes, whatever you want to develop a model for. So let's begin. Initially, we will start sentence by sentence, like what does each parameter mean in the code, and thereby then develop the model based upon the understanding of the code. So when we start writing a code in Matlab, if you want to call back that code to run on its own, we have to create a function. So in this code, we created a function called feed forward neural network function. Whenever you write a code, keep in mind that this name and the name of your file should be same, and you should be in the same path of where the code is. So when you are in the same thing, then the code runs without any issues. So let's start about how we have written this code and what are the each elements in this code. So let's start with the inputs. As I have told you, this is the function which we will call to run the code, and what are the various elements which we are giving the input. If you remember from the previous videos, the NN tool categorizes the data into different uh, components like training set, testing set, validation set. So in this case, we will include the data ourselves. We will specify what is training and what is testing to our model instead of taking the default. So that is a slight change from the NN tool what we have seen earlier. So firstly, what does IP mean? IP is the name of the training data set which you will give or which you have saved in your workspace. TA refers to the training data set target. So you give the input data. What is the output you want it to produce? So that is the name of the file you will give in the TA. What is JP? JP refers to the testing data set. So this is the data set which you want to give to the model without showing what the output is. So you ask the model based upon the training whatever it has done to give you a result based on this input. And the next variable is n. N here refers to number of neurons. As you people might remember from the previous videos, while developing a model, you will specify the number of neurons which you want to give. The problem in the previous user interfaces which you have used is you have to develop a new model from scratch to change the neurons. So in this code, you can specify the neurons based upon your purpose without changing any elements, without needing to create any new network. So these are the number of neurons which we will specify. And ITR. ITR refers to the number of times the model is to run. It's like iterations, number of times you want to run the model. So if you remember again from the previous videos, you can run the model number of times you want by clicking the training button several times. But the thing there would be, you have to export the output into the workspace and then run the model. Otherwise, the model rewrites the outputs. So in this code, what we have implemented is we wanted to have different number of outputs saved to see how the model is running. As I mentioned earlier in the previous videos, as you run the model, there is a difference between the first output you get and the second output you get, because the model tries to develop a new connection between itself and try to understand it in a different manner. So we wanted to capture how different iterations, different number of times model running, what are the different types of outputs which we will be getting. So those are related to what are the different inputs which we will be giving to the model. Whereas when we come to the what are the outputs which I want the model to give, where y represents the training result. So as I mentioned earlier, our model will be training data set, training the data based upon the input training set and the target which we give. So y represents the result of the training. So you get the training values so that you can compare it and see how the model is performing in training and uh, how much confidence you can have on the training model. Because if your training value, the errors produced in the training are very high, the model performance is considered to be low. So you want to check if the model is performing very good or not. That is why we are saving y. When it comes to the z, it is the result we get from giving this input data set. After training is done, you give this input and the model produces its simulated output. So why we save this data? Because we have the output produced a model and we also have the observed data which we will can compare with to check how the model is simulating the result based upon its training. So that is the reason why we are saving this Z. And net refers to the network. So in the neural network, it creates, as I mentioned earlier, there is a network in which there are connections between input layer, hidden layer and output layer. So we wanted to save this network so that we can use it for getting the output and training data sets based upon our input values. So that is the reason why we are saving the network. So this is what the first line of the code is and what it defines. So as we go on, as I've mentioned earlier, here we are running a for loop because we want to save the results for different number of iterations and run the model for different number of times, either using the same neurons or different neurons. And as we go to the next line, we can see network 1 refers to the network number, and this is a feed forward network which we are specifying. We are calling back to its original code. If you see here, this is the original code in the Matlab where it has various variables in it, and we are calling this original code and saying that I want this number of neurons to develop a feed forward neural network. So when we come to the next phase, as we have seen in the toolbox which we used, the inherent UIs which we have used like NN tool, where we saw a training function. As mentioned earlier, there are several training functions, but train LM is found to be good in most of the cases compared to the various models, although there are newer developments in various other training functions, but we can use this train linear Levenberg-Marquardt algorithm for developing a training function. When it comes to the next line, this refers to the number of fails you want the model to run through. So whenever the model is running, it tries to check how it's able to train the data set. So this defines how many times you want it to check itself. This generally is 6 in default. If you remember the NN tool we used, we can specify however how much we want. And next, when we come to the next line, these are the gradients. So there is a gradient of the result which changes as the model runs. So here you can change the gradient of the data set based upon your further understanding of the model and how you want to train the model. But in this case, we will be leaving this to the default, and I'll be touching upon this in the further videos. And similar to this is these two parameters we will be discussing detailed in further videos, how we can change this so that our training model can perform further better. But for now, we can leave these variables as uh, default and try to understand how we can change the remaining variables to develop a good model. So I'll be leaving these three for further explanation in detail in further videos. So when we come to the next line, this refers to the number of EPCOs. If you remember, this is the in the training network figure, it shows the number of times the model is running to check whether it is correct or not by itself. So this generally is 100 default, but you can use the number whatever you want to check how the model is performing, to give it more time for it to run and get a good training. So this is the line that explains it. And when we come to the next line, we'll directly come to this one to check what the network is. So if you remember, this is the training network which we have seen in the NN tool again. So here what are we giving? Until now we have defined what are the various parameters we want in a network and what are the number of codes which number of neurons it will be running, and what are the number of iterations it will be running, and what are the inputs which we will be taking. So based on that, we know this is the network name. If you see, every line has net1, net1, net1. So we are calling upon that network where we have specified all the elements and then calling upon the input data set and target data set. So again, in this, if we see, why is this single inverted comma placed here for both the elements and also here and here? So the reason is, as I have mentioned earlier in previous videos, the neural network tool in Matlab takes row matrices. So as you can see here, we have column matrix 47210 rows by one column. So this is the data which I have. So these are in a column matrix, if you see. So if you are having another element, it will be by 2, by 3, by 4, so on. These are the input variables which is in one column. So what I want the network is to not create any issues to the network. I am providing a one inverted comma. It represents transpose. So what does it do? It transposes the data into 1 by 4720 in itself and preventing any issues from developing while creating a neural network. So the same with training data set, we are transposing it and a network is created. So once the network is created, it trains itself based upon this elements and this data sets. So once all the training is done, then we are asking it, see, you have already trained a network saved as net. So what I want you to give is, based upon the input which you have taken, just give me the outputs of the training. If you remember, as I mentioned earlier, you can see here IP is the training input data set. So we are giving the same data set and asking it to give the training value results. And why again I have given one outside is to get a column matrix here. We are just transposing it because you get a row matrix here if you just provide this one, but I'm transposing it to get a column matrix for my understanding. That's it. You can leave it as it is if you feel comfortable with a row matrix in your results, or either you can transpose it later, but to have less effort in the further process, I just gave it as I wanted it to have a column matrix output. So in the next step, we can see that we are getting our results, the simulated results. What are we saying it again? We are saying the neural network, just going to the network which you have developed. We are not creating any new network again. We are just going into the network which it trained and giving it the output, the input which it has not seen. If you remember what I have told, this is the input set and this is the training set. It develops the network based on only these two. It has not seen what we are giving here. And it also does not know what is the output you will get when you give this second input, the simulated data. So we give that data here, we ask it to simulate it again. Go into the network and simulate the data. So after giving this, the network ends. That is for one loop when we start iterations. For suppose if you give only one, the model goes in this way one time and just stops. But if you give to 1:2 here, first element it runs and then for the second time it runs again. I'll be showing you both for your reference. So as you have seen, I've already given the input and target data sets with satellite precipitation as input and observed precipitation as output. So let's train a network and see how it works. So once you have this network saved in the path you have, the only thing which you need to do is copy this first line, paste it in the command window, and then specify how the inputs you want. If, as you remember, you can take 70-30, 70% for training and 30% for testing. So in this case, I'll be just taking first 3000 to understand how it works. So what is the training data set which I want to give is input, the name is input here, input of how many rows do we need? Let's see, 3000, comma, first column or all columns. So what does this mean? Input of, I want it to go into the input and take 1 to 3000 rows. So 1 to 3000 rows I want it to take of what columns? Of all columns. Here I have only one. Here this is 2 represents all columns. So I have only one, so it will take 1. Similarly, for training the data set, we will give the name of the training set. Here it is target. Again the same number of elements. Just keep in mind, if you don't give this same elements for training, it does not run. It gives you an error. So similar to this, we are asking it to take 1:3000 elements and train the network. And to test the network, what do we need? Again, testing, I want to give the remaining elements in the input. So I have 3001 is to 4720, all columns. What does this mean? This is the testing data which I wanted to test. So the first 3000 elements it's training and 3001 to 4720 it's testing. So after training it will take this in and try to give an output. So here let's assume again the default neurons as 10, and for this case we will say we will ask the model to run only once. So I'll go through this again. We could just copy pasted it. IP is the training value, so we have given the training length. TA is the target data. We have given the same target of the input because we want the same elements to be trained, same number of elements. And JP is the testing data set, and here if you see I want 3001 row to 4720 row in the input to test, and these are the default number of neurons. This is the number of times I want the model to run. So when we press enter, sorry, function definitely. So you should not give function, only the first from here to here. Function again because it's just for saving, it's my mistake. Okay, let's enter. If you see, we have mentioned 10,000 calls, so it's running. The validation checks, if you remember, we have given 1000, so it tests until either of these two or one of these elements is satisfied. So before going to this, let's see what it is showing here. Firstly, these are the results, so let's not go there, we'll go here and check it. It shows the name, what are the info we have given, number of inputs, number of layers it has developed, number of weights it has taken, and other random stuff regarding what the model has developed. If you want to know what are the weights of each layer, you can go through this. You can put the same thing in the network and it will give you from the network, which I'll be showing in further videos again. For now, this model has been completed, and let's see how the model is developed and what is its accuracy. So when we go to the performance, you see at the best validation performance we got it at AppCos 8, the mean square error of 141. So we'll discuss about this in further, but first we will see the regression plots to check how it is performing in training, validation and testing again. So if you see, while training, based upon its thing, what it has observed is 0.35 in training, validation is good, but the testing data set, if you see, it is not able to produce a good result. It's actually showing negative value. So it's not a pretty good model, if I can say. So, but let's just check the results to see how it has given us the result. You see, this is the output which we got, and if we go to the 3001th column, sorry, row, you see it has 0 value here, but our projected is saying 1.62 and so on. And yeah, these are the differences. If you can see, the values are having quite a lot of variation in terms of the results produced. That one reason can be because if you see, the lowest value is 0, and let's plot it to see what are its lowest and highest values. You can plot it by just selecting it and clicking plots and plot, or directly write plot of input. You see the values are from 0 to 200. So it's quite a lot of variation. When the neural network is training, it has quite a lot of change. So it's not able to understand well how how to convert this data into our required values. So that is the reason why you're not able to get a good result. So, and yeah, if we see the network, it will just show what are the various elements in it, and other stuff you cannot view it because it is a network, it's not an input data, but we need it so that we can get the output of what we want. So for now, let's leave the accuracy point, and I'll be more focusing on the development. How to improve the accuracy I'll be giving in the next videos, because the length of the videos becomes quite long if we discuss everything in one. And yeah, so let's see how we can get more results. If you see, we have only one result here in y. Why? Because we have given only one iteration. So if you press the upper arrow, when you go to the command window, and if you press the upper arrow, you can see all the code which you have used previously, and you can just go there like pressing the upper arrow twice, and I just gone there, and I can change the code, instead of copy pasting it again and editing it, we can use this simple method. Let's say I want to give 2 neurons here. So the model is running again for the first time. This is its first run, and again it's running because I have asked it to develop 2 networks this time. So it has completed its 2 runs, and if you see, this time the result is quite good for the second run. This is the second run figures. 0.4 validation was quite low, but in terms of testing compared to the previous one, at least this is positive and positive to it, and the overall uh, correlation is around 0.368. So this is okay for now. Let's leave the accuracy point and see here. If you go here, you can see the networks developed are 1. What happens when we put 2 here? It develops one network, gives you output, and then develops another network and gives you the second output. So that is the reason why we need to save it. So here y of all rows comma ith column. What does this do? It takes this thing into consideration, I, the number of times the model is to run, and saves it. So that is the reason why you are getting 2 columns, 2 results for 2 times. So if you see, the first time it was giving the value of 1.8 and so on, but the next time it developed a different interaction among itself and has given the second result. In the same way, you can develop n number of models to check how this 10 neurons is working out for you, or you can change the neurons and again save it. But be careful to save this data. If you like the result, you can save it into a different name in the workspace by going here and save, so that when you change this data, it does not get overwritten, or just change the name here. So this is how you can use this code to run the model and to control various elements like number of fails, number of times you want to run it, what are the number of neurons, and number of times the whole model should run, how it should save, and what are the different datas you can use while developing this network. So yeah, this is the code which I've mentioned earlier. And yes, if you have any doubts or something is not clear in this video, you can put comments in the chat and I'll be addressing them as soon as possible. And for now, if you see, we have just discussed about the results. In the next video, I'll be showing a code developed by IHE in Netherlands by Professor Gerald in around 2004, if I'm not wrong. This code, you can get all how to check the errors. you see here, we are just getting the results. We don't know how much correlation it is, how much error it has, how much RMSE it has. So in the next video, we will be discussing about this, how this code works and how you can use it to minimize your work when you develop a network and try to check its accuracy. So that is it for this video. If you like the video, please subscribe and share it with your friends whom you think this will be useful.